Hello, everyone, and welcome. Again, my name is Ryan Kelly. I'm a staff systems engineer here at VMware. I've been with VMware about 4 years. I was previously a vSphere admin. I was in corporate IT at a global pharmaceutical company for about 12 years. I've deployed vSphere on 5 continents and then since graduated to VMware. And this presentation came out of sort of a observation from last year. So last year I was working the booth for what we call vSphere integrated containers. And a couple customers came up to me. First were asking, what is this whole VIC thing? And then I explained it to them, and they're like, well, what is a container? And I guess we sort of assumed that a lot of our customers knew and understood what containers are and how they operate. And so what that resulted in last year was a blog post which had over 1,000 views a month. And then I turned that into this presentation, which you're about to see today. And I'll go through the presentation. I've left about 15 minutes for questions, but if you could hold your questions till the end. And then we have microphones available. We are recording the session as well, so if you could just step up to the microphone and ask a question, we'll have plenty of time for you. But hopefully by the end of the session, what my goal today was to make you experts in containers and just give you some resources and some tools to go back and further explore this technology and how it applies to you and your job back in the data center and how you can utilize vSphere to deploy containers successfully and easily on VMware's technology. So this is just a disclaimer. The presentation may contain some features that are not actually generally available yet. Some of them are in beta, and I'll point those out as I go through it. And then other technologies are not VMware technology, so they may be from a third party, so we don't guarantee or support any of the results for those technologies. And then, the technical feasibility in the market demand, may affect when we actually finally deliver it, and we have no commitment to deliver these any date or time. So get that out of the way. That's legal jargon. So a little bit of an agenda. What I'm going to do is start with a real quick and easy kind of easy guide to what is a container, and then I'll jump into why developers love containers, and this is just from observations I have in the field, talking to customers about why their developers have gravitated toward this new technology. Then we'll do a quick demo. It's an easy demo that you could do today on your laptop after the session or in our hands-on labs, and then some information about why does this matter to you as a vSphere admin. The containers, the developers are really starting to control what's being done and the costing and the budget for the data center now, and we want to make sure that they're as happy to run their applications and their technologies on a VMware platform. And then we'll show you how VMware can help today, and then again we have time for Q&A at the end. So let's jump right into what is a container. So just a show of hands in the audience, how many of you have heard of VMware's ThinApp technology? Okay, good. So this next slide will make sense. So a little bit of a summary of what ThinApp was. So ThinApp was a way to package Windows applications into kind of a software-based container, you could say. But it was mostly derived around, and the benefits of it was for the user's desktop experience to make administration of the desktop easier. But it was also nice because it made things like the vSphere client, the FAT client or C# client portable. Like you could take it on USB and run it on servers without installing it. But it really kind of started this evolution of packaging applications into this smaller format so that you don't actually have to install the binaries or install the registry into the operating system. It's portable between different operating systems. So what a container is it's not for Windows today. It may be at some point, but containers are really kind of the same thing for Linux in some way. What they've done is they've taken all the binaries and bits and code to install something like an Apache web server or a MySQL database, and they package that into what they call an image, and that image can be much like a MP3 on your phone or a portable device, a song, but it's actually a container that spins up on their laptop or within a server in the data center or within a public cloud very quickly and easily, this environment where they can actually stand up and develop their software or their code. Well, containers aren't new. It's a little spoiler alert. They're actually a little bit of an older technology. So just to give kind of a history lesson, it started back in 2000 with free BSD in jails, and then Solaris containers were popular for some time. Then OpenVZ in 2005. In 2008 is where it got interesting because LXC, which is a foundation for containers on the Linux operating system, became part of the Linux OS and part of the deployments and branches. And then VMware invented this thing called Warden, which was really the first container runtime system. And then we packaged that off to Pivotal as Cloud Foundry. Apparently we didn't know what we had there. And then in 2013, Docker comes around and suddenly changes their name from .cloud to this new Docker technology. And they had a free online runtime system where very quickly from a command line, you could just download this engine, run a command, you have Apache, MySQL, and developers just swarm to this very quickly. And then there's also other projects going on. So in 2014, CoreOS announced that they would do Rocket. I've yet to see a Rocket container running. And then also Windows and Microsoft have announced that they may package applications in containers, and they're doing efforts for that. It'd be interesting to see as well there, too, a 16 gigabyte Windows container. I don't know how well that's going to work, but so enter Docker, and Docker's really the name of the game in this field right now. So the way it works out of the box, like I said, you can download this Docker toolbox. You have this Docker engine. All of the containers and images are stored out on Docker Hub. So instead of you having to actually reinvent the wheel and develop and package a container, like invent an Apache container, you can go out to Docker Hub. It's all community-driven content, so you can search there, I need Apache or I need MySQL, and 9 times out of 10, there's already a container that you can run, so it made the adoption rate extremely progressive and fast, so that instead of people having to go out and develop all this code, they could just run this. But if you look at this kind of packaging system, it should look very familiar. So it's very similar to something like Fusion or Workstation. But you can think of this as kind of the Fusion for containers. That would be the Docker engine. And it's nice to run containers on your laptop or on one machine, but where it gets interesting is when you want to run it in the data center in production, and you need something like a scheduler to run it on multiple machines at the same time and actually schedule it across different workloads. And I don't know if it's pretty obvious here, but this probably looks similar to what we call vCenter. So this is Kubernetes. There's also Mesos and Swarm from Docker. But the goal of these scheduling technologies is really to answer that question: how can I schedule workloads across like a cluster of servers and orchestrate, if something happens and a server powers off, how am I going to restart it on another server? So very similar to kind of like the whole vCenter concept. So you can think of Kubernetes and those as like the vCenter of containers, essentially. So what's the difference between VMs and containers? As we know, a VM is an operating system, and it has an app installed onto it, and then you can carve up a physical piece of hardware using a hypervisor, into these multiple VMs. It's something, obviously, we're here at VMworld, 25,000 people. We were successful at that. And then what a container is really, it's saying there's a host OS, there's a shared kind of bins and binaries, and then the containers really need nothing else but that Docker engine to run. So they can have a very stripped down operating system, and you'll see in some of the future slides, VMware has brought to market an operating system that's very slimmed down, scaled down, has very little code, boots extremely fast, can run these containers on it, and we've also implemented that into some of our technologies into vSphere as well. But just a kind of side-by-side comparison so you can see the difference. So why do developers love containers? This is, for the last 2 years, the $1 million question I'm trying to figure out, and I've talked to a lot of developers and finally gained their trust to give up the information of, why is this phenomenon, so relevant, and why do you like it so much? And it's really about, what Facebook and things like Google and, Uber and those kind of Airbnb, Netflix, those kind of startups really brought to the market is being able to develop code in this way where, it's very agile. They're not doing these major releases. So like, Facebook back in 2007 or 2011 when it came out, you didn't really notice there wasn't like Facebook 2 and Facebook 3. There's just been the Facebook forever, but now all of a sudden you can respond to comments or posts, and you can say, I like it, I can put a heart or a smiley face, but you never notice that anything changed. It's the same with the app on your mobile device. You have version 44, but you'll download it every time because they're so good at developing and upgrading and iterating code that it's going to work whatever changes they make. And that's really what these developers are going for, is to do these changes, iterate. I want to add a new drop-down to my checkout system. I want to add American Express or Visa as a payment processing. Go ahead, test all that. Let's roll it into production very quickly. Containers give you that speed and that edge to keep up with your competitors, to make sure you're having those things as part of your technology or your offering before a competitor or a startup gets to it. So developers are in this continuous cycle of consuming resources. They're not the traditional developers you may see using vSphere, which is very much a waterfall. So, you got developers that are developing Windows or, Oracle databases. It's very much those machines stick around a long time. These type of developers are doing what we call more of a cattle approach, where they're spinning up machines, they're doing a test, and they're destroying those machines over and over again. So they're going to commit code to some sort of repository like Git. They're going to provision a system and push all the code to it. They're going to test it using some automated testing framework like Selenium, and then they're going to destroy it, and they're just going to do this over and over again until it works right. So very quickly, 5, 6, 100, we have customers doing 25,000 VMs in a day. They're spinning up, tearing down constantly, trying to get to that point where it's at least 90% accurate, the test, everything in the UI drop down correctly, roll that into production, and just keep moving forward. So before containers, the basic workflow, and this should look familiar to you if you're a vSphere admin, is you got your developers, they come to you, they're like, I need a VM. They open a ticket, you spin them a VM on vSphere, they use some sort of integration or configuration management. Chef, for example, pushes the binaries and sets up the middleware, the Apache or web server. And then Apache's pushed down, they pull their code from Git, they have some custom scripts, and then, 25 minutes, or some customers, without some of our automation tools, up to 6 weeks or a month, they get a server, an Apache server. But the whole time they're twiddling their thumbs like, I'm trying to build this next gen app, and I'm trying to do it quickly, but it takes so long for me to get this thing stood up. So they went to Starbucks, and they sat in a beanbag, and they downloaded this thing called Docker, and then they did this Docker run command, and they're like, ta-da, it's done. I don't need to wait for you anymore, because I can do this, at home. I can run all my unit tests, but the problem is it's a constant, developer dilemma. Is they're going to say, when it gets to production, if something doesn't work, they'll be like, but it worked on my machine. It was fine. But now I put it in the production, there's something wrong with your data center, or the network screwed up. I don't know what it is, but it worked fine on my laptop. So with that, I'm going to go ahead and jump into a quick demo. I'm just going to show you how this works. And it's a very simple demo. It's using a container that's out on Docker Hub. It's under VM to Cloud, my label. And then it's just a WordPress blog. It's the same blog I use for my website. And I actually use it to kind of iterate changes when I'm trying to test them. I'm going to add a new theme or a new feature to the website before I blow it up for you guys. So what I'm going to do is, just like that hipster developer at Starbucks trying to start the next Airbnb, I'm going to start up a Photon OS, and this is freely available to you as well. It's an image you can run in vSphere or on your laptop. And then I log into it, using root and password. And then I'm just going to do a Docker PS. I'm just going to see if there's any containers running, just to show you there's no smoke and mirrors here. I have no containers running on there. And then this is out on Docker Hub, and you can search for VM to Cloud, and it gives you the whole command there too, which is really nice. So just Docker run, -D means it's going to run persistent. I'm redirecting the port 80 back to port 80 on the container. If I can type correctly here. Just pretend like I'm typing there. It's really live, folks. So what you'll see now is the layered file system coming down, and this is pretty unique too. It's just a little tidbit of info. The layered file system is cool because most of those layers are duplicated. So if you're pulling down multiple containers, you'll see here I'm pulling down like 16 layers. But if you pull the next container, it's likely they're only going to pull one layer down. So it's very fast, and they built efficiencies into it. So you got to give a lot of credit to what Docker has done. But you see, just like iTunes, I go out, there's a song I want to play. It's the same thing. There's an image I want to run that runs this web page, but I don't have to go to some blog or some manual and learn how to install PHP and MySQL and WordPress. I just run this image and it's done. Then I just get the IP address. And you see on my laptop, I don't have to use some public cloud or anything. I don't even have to have a Wi-Fi connection, except for pull the image. And I got WordPress up and running. Typical web app, same technology that someone would use to build some e-commerce site or some new web 2.0 startup. And I'll log in with my weak password. VMware one bang if you wanted to access the site. Or any hands-on lab for that matter. And if I can type my name. But you see very quickly a full-featured, web application. This is just to give an example of, building something from a container. But most of these developers are going to build, a full container, multi-tiered app. They're going to push a database, a web server. They're going to network that all together. But they're going to do it so quickly in that script. Then they're going to push code to it, run some unit tests, tear it down. But you see that speed and efficiency is so much faster than having to log in, get a VM, run chef, run whatever packaging scripts, and then the consistency is there too. So over and over, you're getting that same consistent experience where you're not worrying like a script didn't run or it couldn't reach the chef server. Very fast, efficient way to develop software. All right. So this is just to give a more broad example of the common developer framework or pipelines. Initially, from their beanbag, they're going to commit and check in the source code to their source code management. Git is going to have a new version, and then what's going to happen is something like Jenkins will see the new build is available, and it'll automatically push a new system and provision it. And where it gets interesting with containers is, like I showed you with the VM, even if you had it fully automated, that's several minutes to spin up those VMs, and again, all those disconnects or issues that you could have with actually provisioning it. That what they want to do, what developers really are excited about, is getting that time of provisioning down from a few minutes to an hour to just seconds. So it's that many more changes in that day that they can do, and that many more, in a week's time, they could push so many updates to the system that they could beat something like if they're competing with Uber, like Lyft could actually integrate new features faster than Uber and maybe steal some market share away. So this is kind of just an overview of what the developer focus is. And it's also an opportunity to re-architect traditional application stacks. So what we call and refer to as the monolithic app is on the left. And so that's your traditional, Oracle, vSphere, WebLogic, a big iron server, has a lot of, everything installed into that same OS and operating system. And when developers want to make changes or upgrades to a certain part of the system, they have to coordinate with all those different groups to actually make those changes. So they're going to have to talk to, get everybody in a room together, the database team, the developers, say, I want to make this change to the UI. Everyone's going to have to agree. They're going to have to run all these tests, build all these new systems. And when you go to what we call microservice architecture, you put everything, each individual component, each function of the application, break that into a container, and then have a RESTful API into it, so that when you make a change to your system, all you're relying on is that I still get the same response from all those other components. Like, this is the Uber example, so it's, the passenger web UI. As long as that container is intact and I can still call all the interactions I need for my functions, I can make changes to the passenger management system without affecting the entire operating system of the application. So it's kind of an overview or intro to where they're going with microservices. But these are, more, what I see is more really bleeding edge companies are doing this. It's not traditional enterprises yet, but it will be there, I think, in a few years. So it's something to look forward to, but I wouldn't say it's, tomorrow go re-architect your app as a microservice. So now we know about containers. Hopefully it makes sense, how they work, why developers want them, but why should vSphere admins care about that? You guys, you do VMs and provision vSphere, use VROps, you understand NSX or vSAN, but developers can kind of do whatever they want, but it does matter because the developers love these containers. So one way or another, they're going to try and get into production at some point, and they're going to be like, either I put it on vSphere and you make it work the way I need it to work, or I'm just going to go get my own servers, or I'm going to go to Amazon or some other data center. And obviously they're way smarter than us. So they graduated MIT when they were 12, and they could get a job at Facebook anytime. But they love Docker, so you'll find out real fast that either they're already running it, or they're thinking about running it, or they want to try it, and they're not trying it on vSphere at this point. But there's still a lot of challenges to running in production. Even if they got their own system or their own servers, or spin up their own environment, somebody's still got to monitor that and manage it. So someone's getting the call at 2 a.m. when that application's down. Because running containers in production is a lot different than running on the laptop. On the laptop, you're like, I got Docker, it spin it up, it just worked. When you're in a data center, there's things to worry about, like high availability, security, there's disaster recovery, how you can do monitoring of the app, how you can diagnose and troubleshoot that. So how you can actually look in, what's already pretty difficult to look into a VM and try and troubleshoot like some Java memory error. Now you got a VM that may have a container and then Java inside of it. How are you actually going to be able to see and have visibility into that? And then all the accounting and portability about, just everything that comes with running an enterprise application in an enterprise data center. It's the same issues and problems you're going to have with a container. The container or Docker is not going to solve that. And then, how can you manage it with the existing infrastructure investments you have? So instead of, deploying new technology or re-architecting your technology, wouldn't it be nice if you could just use vRealize operations to monitor these things, and then it just work with vCenter? And it can. So, what VMware's done is we've made heavy investments here, and they weren't investments like, our R&D was like, this is the best way to do containers. It was much more, we talked to folks like yourself, and we said, what would be the best way for you to run containers, and what would make the most sense? And most of the answer we got was, just make it run just like a VM. I just want to see it in vCenter as a VM, and I can manage it, because I can do everything I can do with a VM, like a vMotion, VROps works, NSX works, vSAN works. But to do this, to make the developer happy, it was a little bit tricky, because the developer, like I said, they want to work in that command line interface, in that command line world. They don't want to open a ticket. They don't want to call you. They don't know what a vSphere client is. They don't know what VROps is. They don't want an automation portal. And what we've traditionally done with these developers, as you know, is when a developer comes to you and says, I need an Apache server, a MySQL server, a SharePoint server. What we do, our immediate response is, here's 6 VMs, go install it, go do what you need. And that's not really what they want. They don't want a VM and then they have to install something on it. They just want an environment to actually deploy and develop their code. So what we've done is we've integrated containers deeply into vSphere, and we've done it in a way that is seamless integration for the developer, but also all the advantage for the vSphere admin to be able to see a container just like it's a VM. So how we've done it is we have a virtual appliance that we deploy that actually has the credentials. You'll input the credentials to talk to vSphere to actually have some sort of rights over a cluster or some sort of area you've carved out. And then you'll carve up a certain amount of resources that are just for this container runtime. So any containers deployed, they'll be in this subset of your infrastructure. That could be as big or small as you like, and you can oversubscribe just like a cloud. And then we'll have some technology we'll deploy onto the ESX host to be able to do what we call instant clone. So to make it very fast and efficient, we are doing a one-to-one container in a VM, but we don't want to have that time of spinning up and doing a clone of the VM. That slows down the developer's process. When they're used to getting a container in 2 minutes, it can't be 25 minutes. It's just not going to work. So we use instant clone that hot clones or forks off a parent VM machine, then push the container into it. And then what we provide the end user or the developer is an API that is completely Docker. It's completely seamless. We're not doing anything magical to make it like Docker for vSphere. Everything they've done on their laptop, back at Starbucks, they can come into the data center, point their Docker host to vSphere integrated containers, do Docker run just like I showed you in that demo, and it runs. They see a response. They get the IP address. They can go to the web page. In the back end, what's happening, though, is it's actually spinning up a VM onto vSphere with a container in it. And like I said, the advantage is now all of your tooling, all of your processes work because it's a VM, so your change management system, your billing, all your monitoring, all of your troubleshooting and diagnosis tools, they're all designed around VMs. Now it's a VM, it just has a container in it, but you also see displayed, we'll make updates to the vSphere client, that in the tree view, you actually see a view of all the containers right next to VM, just like they're a VM. So really what we're trying to provide is, the best of both worlds. So we're saying, manage everything still with vCenter, use all of your tooling like Log Insight works, your SRM for protection and disaster recovery will work, your tooling like vRealize Operations works, NSX is fully integrated, so when you deploy these containers, they can utilize any of the NSX networking or any of the security or the firewalling or microsegmentation immediately applies to these containers. You don't have to retool or reinvent the wheel or anything. And then you can run these containers side by side with your traditional apps, because what we've also discovered is even though a lot of customers are containerizing some components of the application, we found that most of the databases are still running on Oracle in a VM, or they're running a part of the component, like a billing component, is running on SAP in a VM. So there's still going to be some time where there's going to be this mix of containers and VMs, and it's nice to have a platform that can support both of those. So what we've done as part of this integration as well is that Photon OS that I mentioned earlier, which again you can download and go try and play with, that's part of vSphere integrated containers. So every time we spin up one of these container VMs, we're actually using Photon OS, which is a very minimal runtime. And the reason we did is because we actually wanted to minimize the boot time, but also the attack footprint that we're surfacing with these containers, because we didn't want to have a VM that has all these security and all these ports you're going to have to block. We stripped out everything from the Linux kernel except what it needs to run Docker Engine. So there's nothing else there. So there's no binaries or no SSH you can attack, or anything your security team's going to jump up and down for that this won't work. It's very much as close as we could get to containers running natively on ESXi without actually changing the ESXi kernel to accommodate that. And then if you're concerned about security and data, what you saw in my demo earlier was going out to Docker Hub. So I had to go through the corporate firewall, if there was one, to get out to Docker Hub. I can store containers there as well. I can log into that system, but it's not controlled by your governing policies and security. So what we've done, VMware has introduced VMware's Harbor. So Harbor is a on-premise replica of the Docker registry. So it's same functionality, same upload, download of images. It's role-based access. It also provides replication, so you can replicate images both between different data centers or between clouds, even if it's not a VMware cloud. So if you want to have images replicated out to Amazon, that's certainly something you could do with this. But it's really to address this concern that we saw with customers that they're not going to be able to go from integrated containers and pull out from the internet. It's just part of their policy won't allow it. But they're also, they have some sort of intellectual property they don't want to store out on a public internet. So things like governments or pharmaceutical companies, credit card processing companies, they needed something like Harbor. And Harbor, again, is part of our open source initiative. So you can go out and download that as well from our GitHub. And then there's some installation instructions on my website as well to make it super easy. It runs on Photon OS. It is in a container, but it's a registry for storing all of your images in the enterprise. And then we also have introduced this week an upgrade to our solution called vRealize Automation. So we've put in beta some new features. These are features that are available today if you're already a customer of this. And this is really about containers as a service. So if you wanted to put some sort of policy and governance around containers, or you wanted to provide some other ways for your developers to consume containers on vSphere, like you just want to give them, they're familiar with Kubernetes, just let them deploy a Kubernetes cluster on their own, or they wanted like a Mesos or Swarm, or maybe you want to do some sort of Cloud Foundry spinoff where you want to have just Apache or MySQL as a service. Behind the scenes is a container, but the developer just sees an Apache web server come up. They don't really know or care it's a container. So it could be a way to do kind of a PaaS or platform as a service offering with vRealize Automation. So just to kind of summarize what this does, vSphere integrated containers, it's much more about addressing two concerns that we've seen with our customers. Is the developers want a way to consume resources very fast, without friction. They don't want to wait for an approval. They don't want to have to open a ticket. They want the same experience that they've used. They want all of their build and development tools to integrate day one with this system. But on the other side of things, it's not a free-for-all in the data center. So there needs to be some control, and the vSphere admin really wants some sort of policy and control of, we want to put a quota in place. We want these containers to be placed in a certain cluster or data center. We also want to apply some sort of network policy and control or firewall around them. You may want to have some sort of sandbox because, some of these containers that they're pulling, you don't know what images are on there. So you may want to put them in like an NSX quarantine sandbox where it's like, you can do whatever you want within this sandbox and, run your containers, but we just want to protect the rest of the network in case there's some escape from that container that it had some virus or some sort of attack mechanism on it. So it's a nice way to have that control without impacting what the developer really wants. So you're trying to really win over the developer in a way that, they're getting what they want, but you're getting the policy and control that you need to actually deliver this as a service to them. But you're also getting that peace of mind that it's on vSphere, it's something you know. So when you do get that page or that call in the middle of the night that the app isn't running, it should be very seamless and easy for you to troubleshoot because it should look just like a VM at this point. So these are just some call to action items. Some places you can learn more. First thing, definitely, I would say, it's the second on the list, but download and try Photon OS. It's something you could do today if you've got your laptop here, if you have Workstation or Fusion, or if you've got access back to your data center. It runs on vSphere as well. And then download and try Vic. Vic is open source at the moment. And then the production or supported version will go into beta later this month. So if that's something you're interested in, talk to your VMware counterparts, your SE or your account manager about getting you on board for the integrated containers beta. And then if you want to try it today and you don't want to have to take a lot of time to install everything, we have hands-on labs with this already installed into it. So if you go to the hands-on labs here at VMworld, it's first come, first serve. They'll also be online afterwards, and those labs are very much a real environment. So they're real vCenter, ESX servers, integrated containers. The nice part is, it's not a simulation, so it's not a click through and everything just works perfectly. The bad side is if you break something, if you power off vCenter or destroy an ESX host, you have to start the lab over. So it's very much a real environment. It'll really imitate exactly the same way it'll work back at your data center when you install the products. And then also something to try out is a new offering that we're working on called Photon Platform. I've already heard some feedback from some folks that that was really interesting, and that's much more the advanced or expert containers course. But if it's if you're hungry for even more after this session, you want to see what we're doing in this space with a sort of re-architecture of vSphere. It is using ESXi, but it's a different use case than traditional vCenter. Check out the Photon Platform session. And then there's a couple additional sessions. So the VMware Private Cloud and Containers in Productions tomorrow at 8 a.m. I have a session tomorrow. It's really going through the use cases for Photon Platform or vSphere or maybe reasons for both. And then we have Zero to Photon Platform on Thursday as well, 11:30. And then be sure to follow me on Twitter, VM to Cloud, and all of the examples, the demo I did today, instructions for installing Harbor and Vic, some examples around Photon Platform, they're on my website. So if you didn't take notes or you didn't get everything down, it's all there. Just really easy screenshotted step-by-steps. You want to go and try it, just go to that website. And then with that, we'll go ahead and open it up for questions from the crowd. And if you don't mind, we have microphones at each side, and we're recording it, so we just want to make sure we get all of your questions. Yeah.
I noticed that you had integration between the containers in VRA. Is VRA 7.1 required? What do you need to do in order to be able to ramp up the containers in a VRA implementation?
So everything I showed you there, I have instructions on my blog. Those are just kind of basic use cases using the IaaS engine. But what we've done is made it out of the box with 7.1, and it's in beta. So you'd need 7.1, but you'd also need to sign up for the beta if you want to try those features. But if you just wanted to kind of see the art of what's possible, there are things you can do today with either 6.2 or 7.
Sure. So with the 7.1 beta, you would sign up for it, and they would give you the bits to install with your VRA implementation, similar to like CodeStream or something like that?
Exactly. So once you're signed up for the beta, then they will issue you bits that have that code in it, and then an unlock code for that particular beta for like a 3-month evaluation.
Okay.
And then part of the agreement is that you'll provide feedback to us, and what didn't you like, and it helps to ensure the product when we go to GA that it works for your requirements as well.
Okay, great. Thank you.
Sure.
Yeah, hi.
Hi.
I just need the demo you did today. Is there a slide available somewhere?
I can't. You got to speak more into the mic.
The slide available for what you did for because somehow I could not take the picture for the links you provided. So.
Yeah. So the question was, will the slides be available after the show? And yes. So the session being recorded, and after VMworld closes, we'll put all the sessions online, so you can download the whole presentation.
Okay. Thank you.
Yeah.
So just, you said you had a lot of experience with the orchestration tools and whatnot as well. From some of the new capabilities we're seeing, like with making the blueprints and automating that aspect of the developer, how do you see those things integrating with containers, and which direction would you invest in providing those services for your developers? So the question is, should you provide as a service containers or just give them the API? Yeah. So what I've seen is a mix of both. It depends on the organization and sort of the culture at that company. Is they very much want to have as a service but with control. So they want to have approvals and some sort of back-end integration into it. And then we've got other customers that are very much, they just want to give the developers environment just to go crazy and spin things up. So it kind of depends. Where I see it going is much more, I think it's going to head towards more the App Store model, where you'll just be able to pick through some sort of interface, click and I get Apache, click I get a 3-tier web app, and then
that's going forward. I think right now we're in the beginning stages where it's very much the developers just have this, granular code to work with. But I see long term it going to what you said, much more a service offering. So much more like, where Cloud Foundry's heading. And that's something where, Cloud Foundry and VMware work well together, is trying to offer a PaaS where, instead of just containers and you got to get the container, why not just offer them the environment they need to develop their work and in one complete single-click package. So, yeah, we're probably not there yet in the industry. Oh, we got one over here.
Yeah, I was just curious, is NSX a requirement to use this?
No, so NSX is not required. Just like running VMs, it would be, that requirement would depend on your use cases of, do you want to provide microsegmentation or do you want to provide some sort of software-based firewalling? But it absolutely does not. So you could run containers, on your laptop, no NSX, and they have some rudimentary networking functions within it, so you can wire containers together, but it's not as advanced as what NSX can do. It's debatable because a lot of customers, do you want the developer trying to network their things together, or do you want to be responsible for that? So it depends on the policy you set for the company that, you may not want somebody to network containers across 2 data centers because that just causes a lot of problems, but, with policy-based networking, that could be something you could apply it when they deploy the VM or the container.
Great, thank you.
Yeah.
So one of the questions I was wondering is, whenever it builds up the VM, is it a one-to-one mapping? So one container to one VM, or could you have one large VM with multiple containers on it?
So it's a great question. The question again is, is it one-to-one, or could you put a bunch of containers in one VM? Currently, with integrated containers, a one-to-one mapping, and it's to address this problem we saw where, the admins wanted to just be able to manage, if I got an Apache container, it looks like a VM. But it's not to say that you couldn't spin up a bunch of VMs, very large VMs, and then they could deploy containers in there. But it gets a lot harder to manage, is what we found out. So we had customers doing that initially before integrated containers, and the developers were coming to them, and they're not saying, I'm going to run containers. They said, can I get 6 Red Hat servers that are, 8 CPU and 20 gigs of RAM? And they gave it to them, and then they had problems, and they're like, well, what are you running? Well, Apache doesn't work. It's like, well, what are you running in there? And they look, and inside the process threads, there's like 5 million containers running, and they're like, I don't know how to deal with this because we can't support it because I don't understand how containers work, and all I know is I have a network and I have storage, and the VM's up and running. So you can do it either way. It's do you want to do it the other way is the question.
So basically, if you're trying to do more than one-to-one, you're not going to see the little container listed underneath of the virtual machine object?
Yeah.
Basically?
Yeah, so you'll see a VM, and then you'll see it's got container 1, 2, 3, 4, or however many they ran.
Okay, so it will list them then.
Yeah, it'll list them out. But the challenge, too, is there's only so many ports available on a VM because you're bridging networking when you're doing it, and that's
Right.
the other issue we saw people run into is when they're trying to run 50 Apache servers, there's only one port 80, so they can't do it. So the one-to-one kind of actually solved that problem, too. But you could do it either way. It's just we've designed and implemented VIC in a way that's one-to-one.
Okay, thanks.
Sure.
Thank you for those slides that showed how developers really look and act. I liked that part of the presentation.
Great.
I have a bunch of knuckleheads, otherwise known as enterprise architects, that are telling me that have to have a container strategy right now. The company is years behind and we can't fall further behind. We need Linux right now. So you mentioned the timeline. You said it's not all that prevalent. So I was wondering if you could help me bridge the gap there.
So definitely the fastest path, you ask anyone at VMware, the fastest path to containers in production is vSphere integrated containers. If you were to start over and say, we're just a bunch of servers in one swarm, I've talked to customers, and just internally, all of the meetings and all the coordination they need to do, they're like, 9-month project with a bunch of people sitting around drinking coffee and trying to figure this all out and then go into like some sort of, pilot and production. And we've had customers that have downloaded VIC and then used it, and then already they could see their change management systems integrated because they're scanning the cluster already. And so immediately it just fell into place for them. So we see it as like with VIC, like, a month probably, because you're going to evaluate it, put it in production, unit, do all your testing. And
I guess I'm thinking more industry-wide. Like you mentioned that it was mostly dev test, not a lot of prod. But they're saying, we're years behind. We're a Windows-only shop at the moment, so that could be part of it. Is they're trying to break that glass ceiling over Linux. But I don't know. You made some comment about it.
You mean just industry-wide, like adoption rate?
Yeah, exactly.
It's very much like in the enterprise, and most of the customer base of VMware. It's very much the developers maybe on their laptop. That's as far as we're getting. And we have pockets of customers that are more advanced, or they're completely a software company like Salesforce, maybe more advanced, but it's the rarity. The minority is the people who are doing full-on containers, microservices. Like I can only mention the ones that do it on like one hand. It's like Uber, Google, and Airbnb and Netflix. That's about it. But like when I talk to my bigger customers, like that vSphere sells customers, they're like, we have maybe a couple developers trying it. That's it. So I don't think we're at the point. I think Docker would like it to be at that point much faster, but I don't think we're there yet because I think there still is so much learning and so much evaluation. And also, a lot of customers I've talked to who've even gone down the road of going to containers and putting it in this process, they went back to VMs because they said the consistency wasn't there. Because the image, it's baked in there, and they want to make changes into the actual operating runtime. And they were like, it was just more complicated to do it in containers. So I think we're still at the point where we're kind of finding out, and a lot of customers are just learning about it and ruffling the waters, but it's definitely not a thing like you're late to the game yet at all. Yeah.
Appreciate that.
Yeah.
Another question is Kubernetes. Is that like something where we'd say, okay, vSphere, we still manage, Kubernetes, you manage, or is there an infrastructure component to, where are these microservices, how many, the scheduling of those?
So I think it's not settled who's going to win that battle is where we see it. So we see that there's Swarm, Kubernetes, and Mesos, and they're all vying for the vCenter of containers, and no one's really adopting either or other. So you go to every customer, that runs those kind of workloads, and it's like, Kubernetes, Mesos, Swarm. There's no de facto yet, but I think with what we're doing with vSphere integrated containers and Photon, we may actually have fallen into that market ourselves, and we may actually win that market too at some point. But I think there's still some time. The jury's still out on like which one it's going to be as the overall container scheduler.
Thank you.
Oh, sure.
I was actually getting ready to ask exactly whether there was an integration strategy in the roadmap for mapping into Kubernetes. So he already asked exactly what I was about to ask.
Sorry.
I can kind of elaborate. We are doing investments into some of the NSX microsegmentation into Kubernetes. So we're working with them to talk about when they run commands in Kubernetes like install network or add firewall.
Yep.
We would like that to be an NSX load balancer, and so that's some work we're doing, but it's not as high on the radar as things we're doing with integrated containers and with Photon platform itself. But we definitely want to be relevant in that space. And then we also want to make sure that things like vSAN too can work as a storage volume. So we've actually introduced products there as well in beta that we have a volume driver that works with vSphere volumes and vSphere vSAN. So we're trying to make sure VMware's in there, but it's giving the customer still choice of you don't have to do it our way. You can still do it with whatever tools they're giving you, but just make sure it runs happy on VMware is our whole goal. Yeah.
Okay. I think if you all want to end up being the leader in that space, I think getting away from the one-to-one mapping is going to be a critical factor.
Yeah,
it's I can tell you from where my developers are going is they want a bucket of nodes, and then that constitutes their playground and their area, and then they want to go, do their stuff in that bucket, not one node, not spin up a set of separate nodes for each container. So,
I'm on the same page. Yeah, I don't want to spoil my presentation for tomorrow, but that's what tomorrow's presentation is about. Now you saw Vic. Now here's the other way we're doing it too.
Cool.
So, yeah.
Thank you.
Sure. Thank you. Hi.
Hey, Ryan. I was curious if you could talk a little bit more about any sort of upcoming integrations between both Vic and Photon as well as NSX. Like, do you see these containers becoming more like objects that are obviously they can be consumed by NSX today as just individual items, but I'm curious about some of the more like deeper integrations that might be coming along with NSX.
Yeah, so some of the things we're working on is making sure that NSX is a first-class citizen in the Docker engine. And that it's taking some time because Docker's iterating changes faster than we're able to QA for each engine or each release they have. But things like I was talking about with Kubernetes, the same thing with Docker engine. We're going to try and make sure that NSX can be integrated. So if you do like a Docker network create command, instead of that creating a Docker network, it'll use a plugin driver and then just make NSX create those networks. And it's the same with the volume. So if you want to create a Docker volume, usually it would be just native, a data path on the actual file system of that VM. But we want to make sure that we use a plugin and then we can reroute that to a VMDK and have that be the actual volume. To make it more easier, I think, to manage, but also, you have physical limitations on the local drive that you won't have on a VMDK. And then you can do things like backup and snapshot easier. Those are some of the things we're working on now. But as it evolves too, our R&D is always going to be looking at if somebody does like a Docker load balancer, couldn't that just be an NSX load balancer?
Also, curious if things like service discovery and whatnot are things like that SBU has been talking about at all. I haven't asked them myself. So service discovery on a cluster of Docker components, like where they actually see the system come up and automatically add it to like an NSX load balancer. That's kind of stuff I wonder about. Yeah,
that's something we're working on with the Arkin acquisition. They're trying to combine those two technologies so that I discover it and then apply policy immediately. But it's going to probably get we're going to have that for VMs first, and then later it'll be for containers. So VMs are always going to get the priority. We're VMware, so. Makes sense.
Cool. Thanks, Ryan.
Yeah, sure.
I'm not sure if maybe you mentioned it and I didn't catch it, but how are the developers accessing VR automation to actually kick off a new container? Is that via command line? Do they have to log in? And are they logging in, or is it?
So they can use our command line, which I'm not a fan of because it changes the way they develop. So what we've done is we've also made other options available so that we could have as a service a swarm cluster. So you could say, spin me up a swarm cluster that maybe is 4 nodes, and then they're getting full Docker API command line. Or spin me up Kubernetes or a Mesos cluster. They're behind the scenes, they're running in VMware as a VM, but what they interface in and program their tooling against is the native API.
But how are they kicking that off in the first place?
They would either log into the portal, click in the UI.
The automation portal?
Yeah. Or they can use the REST API. Depends on, how they want to interface. Most of them would probably prefer to use the REST API just to request, what I see is they'll probably just want to request a swarm cluster once and then do their testing against that. They don't really want to deal with the VRA API at all. Yeah.
Okay. Thank you.
Yeah, I pushed that it should be native, but it didn't go through.
So, quick question. Any plans around OVS and OVN? I know VMware is making contributions in OVN, of using OVN for any of the container networking.
Yeah, so that's something I mentioned earlier we're working on is making sure that like NSX today NSX is for vSphere only.
Yeah.
And as you may have heard, we're decoupling that with transformers.
Correct.
And that's when we'll start to really build those deeper integrations with the open virtual switch and making sure that that's a first-class citizen in the Docker environment. The issue and debate we're having right now is like, which one's going to be the winner in this race? Is it going to be Kubernetes or is it going to be Swarm? And because we don't want to invest in something that's going to, it's like the VHS and beta. It's like, do we invest in beta and then we lost, or Blu-ray and HD? So we're kind of waiting. We are making investments there, and we're showing that we're capable of doing it, but we don't want to push too much time into it if it's just going to be a technology that's going to go away. So.
Okay. And the other point you mentioned, just to make sure I got it right, was that you guys are also looking at lib network with Docker and having NSX plugins so that they can manage the networking between containers as well?
Exactly. So we actually have some code in Tech Preview that does that today.
Okay.
Yeah,
and is that available on Docker, or is that something available through NSX?
It's on our GitHub, so vmware.github.io.
Okay.
There's some code out there for it. Same with that virtual volume mount.
Okay.
And then I wrote some guides on the vVolume, and there's some other folks that wrote some guides on the NSX integration. They're actually here too, the engineers. They're here at the booth.
Okay. Do you know where I can find them? Which area they'll...
There's a CNA booth, like Cloud Native Apps.
Okay.
They're there, and if they're not there, they can, usually most of our folks there can talk to it, or they'll find him immediately.
Okay.
Especially if you're interested in that, this engineer will become right over there because he's super excited about that. I was excited about it too, because when I first did it and I couldn't do NSX, I was like, we're missing this.
Yeah.
It should just be NSX. What's this lib network thing?
Yeah. Okay. Thanks.
Yeah, sure.
Hi.
Yeah.
The guy with the goofball developers again. I
Sure.
plan on giving them this presentation. So, the Photon.
Yeah.
We're talking about bringing in our first Linux distribution and standardizing, et cetera. Is it ready for, it'd be in a development environment. Is it ready? It's a 1.0 product. I guess that's why I'm asking. And would that preclude bringing in one of the more well-known Linux distributions?
I think it's, in my opinion, it's ready. I can't speak for all VMware and guarantee it, but we have actually been using it for 2 years. It was in beta for 2 years. So we were even using the beta to do like live demos. And also, if it's helpful, we are using it. That is our new form factor for, our virtual appliances that we distribute our software in. So going forward, all of our appliances will be Photon OS. So we're banking on ourselves that software we deliver to you is going to run in Photon. And we have several customers that were early beta, and they're already running, thousands of Photon OS VMs. And I wouldn't, worry too much about it being 1.0. I think the benefits are it's VMware, it's VMware supported. There are, I didn't mention, but there's deep integrations to optimize it for vSphere, for the storage and the compute drivers. So that's what makes it super fast. And then we provide support for it too now. So I think it's a good distro, but also it's a derivative of desktop OSD. So it's a derivative of a industry-wide Linux kernel anyway. So it's not like we reinvented it and we have our own kernel. We kind of change it and put our own proprietary kind of blessing on it. But it's a kernel that's been used in production for years anyway. So.
And is there a comparison out there between if I used Ubuntu or Red Hat versus Photon?
Yeah.
Okay.
Yeah. So if you go to that GitHub site, there's a comparison of all the pros and cons of it's CoreOS. Red Hat has they have their own kind of CoreOS thing. I forget what it's called, and then Ubuntu and all of them. And it just shows you the pros and cons. And we're pretty honest. It's like, well, if Ubuntu does something better or is more optimized, it's explained there. But our real features are it's optimized for vSphere. It's easier to deploy than CoreOS. It's smaller and it's faster. So our footprint is like, I think right now it's about 192 megs, and it boots in 3 seconds. And I think CoreOS is still like 500 megs. It's not totally apples to apples to brag about, but I personally prefer. I've tried them all, and I personally prefer using Photon OS just because it's easier and there's more community writing content about how to use it than you go on Google and you're like, how do you do this in CoreOS? And there's nothing. So.
And then I think that it had a couple of the Docker platforms integrated. Does that update differently separately from, or would you just push out the next version of Photon?
You can do it either way. So you can download the newest version of Photon. It'll have whatever the latest Docker engine is. Or we have a Yum kind of derivative updater built into Photon, so you can just do upgrade. There's a command to just do upgrade Docker engine, and it'll just pull from our repository, or you can put a local one, and then it'll have whatever the latest binaries are for it. So it's patchable, it's upgradable. Usually most customers, the way they're using it, when they patch, they're going to just destroy the VM and push a new one, but you could still patch that VM. Because the container, it almost doesn't make sense because the container is so portable, you can spin up another one, but we offer both mechanisms for it. And we're going to build VUM integration into it, so natively in vSphere, you'll be able to update and patch Photon OS too.
Great, thank you.
Hi. Maybe you already told this or not. I can't recall, but I was just wondering about the licensing terms of the Photon OS.
Yeah.
So you can download it, spin it up now, and start using it.
Yeah.
But will this be incorporated into the standard vSphere license in the future, or will you need a separate license to be able to use this?
So at this point, Photon OS is an open source software, so it's free to use with the open source agreement that you won't change the code or redeploy it and sell it, or all the legal jargon. And you can use as many as you want on vSphere or any cloud that you want. But if you want the supported version, that's where you just pay a certain SNS, so yearly renewal fee, that you could call VMware technical support, the same 800 number as vSphere, and get support for Photon OS. But we don't have any plans to license Photon OS at all, or just make it part of vSphere. That may change, but at this point we're really trying to grab the developer mindset and make sure that they have access to this software without going through some sort of license agreement to get it. We just want it as easy as they can download Docker, they can download Photon and run it in your data center, whatever private public cloud you're using. And that's really our goal, is to make sure that we have an operating system that can run across Amazon, Google, has the same exact experience, and you can move everything around. And as you saw in the keynote yesterday too, that's part of our strategy is NSX in any cloud, Photon OS in any cloud, and then be able to have that control and use the same tooling and management system that you've been using all along. So
you got the full featured product, except for the support then?
Yeah, so it's a full version. It's not like a light version, or it's not like, we don't do Puppet or Chef where it's this is the open source and then there's an enterprise version. We don't have any plans to do that right now.
Okay.
Photon Platform, which is a different solution, just the same name, that may change where it's going to be open source and maybe a paid version, but Photon OS is definitely going to be open source for some time.
Okay, thanks.
Thank you. Any other questions, or we're right on time? All right, thanks everyone for sticking around. Appreciate it. Hopefully it was helpful.